Okay, I'm here today as a follow-up video. I've had so many questions about this little injector tester I designed and built to test or clean Etec fuel injectors. Now, I'm going to go over quickly what I have, and I think I understand now why some people are having an issue getting it to work. So first of all, the bulk of everything here is DC to DC, what they call like a buck converter. It'll step up DC voltages to higher DC voltages. So this is being fed right here to a battery. So there's 12 volts in here, and it'll produce much higher voltages. E-tec uses up to, and in places, 55 volts. I have this set somewhere around the 33 volts. And there's an adjustment on here. You can just adjust it to set the output voltage. This is the output. Now what I have is the output is connected basically to a little circuit that I made. And this board underneath is just a generic circuit board. You can buy them. And I just bought it to have something to mount all this to. So I have the output of the converter tied to this large electrolytic capacitor. And that's just to make sure the output is stable, because the pulses it's driving to that injector are taking a ton of current, and it's to try and stabilize it. So I put that in place. The workhorse is the NT2541, NTE2541 transistor, which is right there. Now when your transistor's facing you, it's base emitter collector, I believe, but look at your diagram to ensure that. I've gone over this diagram to make sure I know what I'm talking about when I draw it out for you here. So any case, we're going to take a quick step back here, and I'm going to show you the diagram I made. So before I show you this working, and there's a couple other little details I'm going to explain, here's what I have. We have a battery connected to the DC converter, 12 volts in. Out is the voltage you set it at. Where the output of that is, I have put a 10,000 microfarad capacitor. You may not need this at all. I've put it there just to make sure it was stable before I tried to get this thing working. The positive output, which is also tied to the capacitor, goes right to the positive side of your injector. The negative side of your injector goes to the collector of this NTE2541. Now this is what they call a Darlington pair. It's actually two transistors in one, but for the sake of drawing it, I'm showing it like a regular transistor. The emitter of the transistor is grounded. So what happens is I'm driving the base of the transistor with a 2K resistor to limit current so that you don't burn the transistor when you're firing it. Now, this transistor, again, what happens is when it gets hit with a pulse, it basically connects the negative here to ground, or the bottom of the injector to ground, completing the circuit so that you have a pulse. But that is only connected to ground for the duration of the pulse coming from the pulsar unit. Now, it may depend on the pulsar unit you're using. However, some of the questions, people have bought the same one that I have and it won't work. And I think I know why. This little injector tester, it's made so that it's always providing a positive voltage to whatever injector you're driving. So if I connect my meter to the red wire coming out of the pulsar, it's always 11.13, even when it's pulsing. So if I connect that voltage to here, it's just going to turn on the injector and it'll never shut off. If you look at the black wire coming out of the pulsar, which is meant to connect to an injector, it reads at the moment 10.5. But when I turn the pulsar on, so I just hit the button, it's now pulsing, you'll see it's reading 8 volts. That's an averaged DC voltage, and it dropped because it's pulsing. So the negative is pulsing to ground and up. So the negative is the side that's switching. So the negative is what you have to connect. The negative is what you have to connect to the base. So I'm marking here injector tester, black wire. Your tester may be different. However, this one, the switched line is the black line, not the red line. The red line, even when it's pulsing, if I connect to it now, you'll see it's the same thing, 11.13. So if you connect that, it's just going to turn your injector on and it's going to stay on, just heating up. So at the end of the day, what I'm doing here now, just as a test, is I have it hooked up just to a headlamp bulb because I don't have an injector here today to run it off of. But you'll see what happens here. If I connect the pulsing tester, it's on and it's working right now. I'm just going to adjust this so I can get my finger near it. So it's pulsing now, and if I stop the pulsing, it gets brighter, and that's because it's fully on now. When I turn the pulsing on, it's going to get dimmer, and it's hard to see there. There we go. It just got a little dimmer, just got a little brighter, just got a little dimmer again. And you could measure that, and you'll see that it's not a true 12 volts. When it's pulsing, it's actually less because it's averaging the voltage to read on a regular meter. So I hope that helps people trying to make this work. I'm going to give another shot again here of the diagram. It's pretty simple, but I can understand problems because if you connect the red wire to drive the base, this could be probably a larger resistor. I just went with 2K because it's what I had. But if you connect the red wire, this one here, to the base here, it's going to be on all the time. You'll probably get a single fire and it'll just stay lit. That's the problem. You need to be connecting the black wire. Wherever you see ground, it's just negative, negative, negative. No need to rewire things if you have a common negative point. Anyway, I'm going to post this and I hope it helps some people who are trying to figure this out. Okay? If you like it, please click like and subscribe. Thanks.